Hi, Daniel. Can you repeat the question just so that?
Yeah, so will the quiz be posted on CCLE or Gradescope?
Not directly on CCLE, it will be on Gradescope because CCLE doesn't allow me to have different time for some students with need. So it will be Gradescope.
Okay.
So I'm just going to
Okay,
check.
and then one more question. So I know you said the quiz is going to be based on lectures 1 through 4, correct?
Yes.
Or is it just the general chemistry? Okay,
Lecture
so
1 to 4.
out of the energy conservation, um, so what can we expect from like energy conservation since we haven't like gotten too many since we haven't had homework on that section?
Um, so let me open the slide so that it's easier for you to. Let me go back to the slide. So let me go to CCLE. So that way it's easy to open there. Um, so if you see here, lecture 4 annotated. Let me share the slide. Okay, so let me close all these tab. Okay, so lecture 4. This is what I open in the on CCLE. Okay, so if you think of energy here, you if I give you just a simple formula like you have 1 Newton force and 1 meter, I will ask you what's the total work. So this calculation could be energy. You just have to plug the formula and get the answer. Um, another,
Okay, so like just like a general
yeah,
understanding of it,
as
not
long
like
as
the
yes, not like it.
because yeah, because I noticed like later down in the lecture we get into enthalpy and
No, we don't. So
specific heat.
let's cover this one. Because we are talking about that, let's see what could be question. So this slide number 4 is or 8 here is something that you can think of. Um, Again, you see there is example quiz. Another thing you could to think of is I'll not write any. I'll not ask anything about the unit conversion because that's just specifically finding the right references. For instance, I'm going to go to another slide here. Anytime you see equations, stay there, okay? Because for instance, you know that amount of energy, enthalpy or entropy, that doesn't matter now. Amount of energy required, it depends on mass of that stuff that you have to raise the temperature, specific heat capacity and temperature. So you know at least this equation exists. If this equation exists, I can ask multiple questions on that. If I say if the total amount of water in the system increased by 3 times, how much total amount of heat is required? So based on this equation, you know that it's going to be 3 times more. So you just have to write those equations. I suggest that write these equations so that understand that conceptually. Um,
Got it. And then when it comes to the specific heats, we should have that on our like sheets here, or will that be provided?
so again, this is open book. So you are open. This is not closed book. So you should write whatever you think to get the materials quickly.
Got it. Thank you.
I mean, you can open the entire lecture slides. That's up to you. Just know where things are so that you don't waste a lot of time thinking on it. And also, based on my experience, if you write everything on a cheat sheet, it's more helpful for you. So prepare for it by writing everything what you think on a cheat sheet, so that everything is you can see without trying to jumble through those. Because this used to be a not open book. It used to be a closed book. That means you are allowed to write everything in the front and back side of a cheat sheet. So approach this as a closed book. The only difference is you have the content anyway if you need it. So for instance, this example, you see this is at least given. So mostly I'll not ask you to calculate something. I'll ask you the conceptually. Is it going to increase or decrease? If it does, how much? Because it's simple factor here. So like this one, it says, amount of flow rate that goes to the system has to increase if you have to reduce it more. For instance, if you want to cool it more, you have to flow. If you have to increase the flow rate, because then the amount of water that the heat capacity, the amount of water that need to flow is much higher. Because the more water you flow, the more temperature will drop because water will get that from uh, warmer temperatures.
Can you go back to slide 20?
20.
There was an example that you went over and you showed us how to find delta H,
Yes.
but I was still stuck because the question was asking for how long. So it was asking for like a time. So I still don't know how to find that.
Oh, I see. How long it will take to heat water 40 gallon electric um, to all right. So this is m dot. Okay. Uh, okay. So I think there is a misleading here. So amount of energy. Okay. So this is energy. So power will be dH over dt. Okay. So amount of power is if you remember what is power means, it's 5 kilowatt, right? So 5 kilowatt is power, which is energy over time. So you are supplying this much amount of energy per unit time. Okay. Um, so if you know the power, you can calculate energy over time. So that's it given. And the m become here dm by dt. Okay. Amount of time it takes. So let me write those somewhere. Have you seen the solution in the textbook?
No, I
Um,
haven't looked at it yet.
yeah, you can go. So what we can do is you can go back to the solutions anytime you have difficulties. Check this because these are all in example solutions, so they have solution given. See if you can't understand it, and then you can ask. It's basically there is a time term here, 5 kilowatt. So that's the power. The amount of energy supply is 5 kilowatt times the time. Delta T become energy. That energy is this m times c times delta T. So you have m is given 40 gallon, c is given from here, delta T is given. The here the delta H term is coming from 5 kilowatt. Okay, but delta H is energy, kilowatt is power. Power times time is energy. So here this term will be delta H time would be this much. Okay.
Okay.
So just check that one and see if you can understand. For quiz, again, you just have to think of, is this going to be um, the amount of energy required? Is this going to increase if you add in more mass or less mass? If delta T increases, what will happen to the energy requirement? So that's like conceptual uh, changes.
Um, Professor,
Yeah,
on that question, we're given the specific heat in that table. On
yeah.
the quiz, will we be given the values or are we expected to know them?
So this is open book. So you got to find out. So you should have your slide open, or you should write somewhere. But again, I'm not asking a lot of times the numerical values. So if it is calculation, usually I give you those constant. If it's not calculation, I don't give anything.
Okay, thank you.
Um, any any questions on these? So these are all, again, anytime you see questions, you should be able to find those. See what change the efficiency. For instance, here, if I say how the efficiency will increase, you know that based on the equations, you just have to make the TC smaller and smaller, or TH higher and higher, so that this become close to the zero value. Same thing, another quiz would be, and I give you locations and I'll ask you what form of energy is transported. For instance, if I say in boiler, uh, tell the tell the energy transport, no, which from to what. So in boiler, you know that thermal energy is transported to kinetic energy. So that's what you have to write. because the thermal energy is coming from this burning fuels, and then it goes to the steam, producing steam. That steam is moving, so that's the kinetic energy. But for here, for instance, if I ask what is the what is the form of energy transfer in this burner? So if you see, the incoming is fuel, the outgoing is thermal energy or heat. So that means fuel energy is basically chemical energy. So you write chemical energy transfer to thermal energy. So you got to determine what energies are. So from here, and then you look at any figure, and you'll be able to say what energy is being transferred. So that would be one question. I think so. That's same thing here. No, heat transfer. Just have to see the transfer rate determined by the surface area, difference in temperatures, and the resistance. So if I ask a conceptual question, if the resistance is high, do you think that it will heat up quicker? You say no, because it's inversely proportional to R. A lot of time I'll ask you to explain it, so you can explain either mathematically, or you can explain as a theory, conceptually. So my suggestion is always write those equations. Anytime you see a equation, write those in your cheat sheet and know what those means, so that you can answer those conceptual questions. Same thing here. You see that energy of electromagnetic wave increases with frequency. So if I give you I say infrared and X-ray, which has more energy, you should be able to tell by just looking at this slide. Radiations, as you see, radiation is proportional to the temperature of the body. So if you have a hot body, it radiates more, and it also depends on surface area. And that radiation also depends on, as you see here, its intensity depends on the wavelength. It increases at the shorter wavelength, and then after a point, there is an optimum wavelength, which is 2898 divided by T. But again, I will not ask so detailed question like that. Just know the question here. So,
Professor,
yes, Leah.
I have a question. So during the quiz, are we only allowed to use, say, like stuff we've written down, like cheat sheets and homework and stuff like that?
This is open book, so you can use anything. You can use internet, you can use anything really, but don't ask your friends. That's the only thing I expect.
Okay, got it. So it doesn't matter if we like open a new tab on our laptop and stuff like that?
Yeah, because it's not being monitored, so you can do whatever you want.
Okay, thanks.
My hope is that you have three things you should open it. One is your slide, your note, textbook, and homework solution if you need it. So these are all there. So I think you should go over all those and make a cheat sheet, so that you don't have to keep browsing here and there, because 20 minutes is not a lot of times if you do not prepare at all. So approach this class or approach this quiz as a closed book exam with your cheat sheet, but just know that it's not closed book. Just in case one question give you hard time, just you can go back and look at all those details. Okay.
Professor, could you go like compare and contrast the reactor types?
Reactor type. Okay, so let me see. So that would be lecture 3. Let me see if those are the lecture 3. Yeah, this is the one. Right. What the question?
Just to compare and contrast the
Difference between them.
Yeah.
So the batch reactor is something like, think of your water bottles. Okay, so my glass of water is a batch reactor, because nothing is coming in, nothing is going out, and I take something and just shake it. Okay, and the concentration changes because of reaction. There is no dilution, there is nothing. Okay, so when you think of batch reactor, there is no flow coming in, no coming out, just closed system. Okay, a closed system for mass. But when you think of a completely mixed flow reactor or CMFR or CSTR, whatever it is, the difference between batch and this one is that there is a flow. So imagine there is a pipe coming in, going out. So think of your bathtub is a completely mixed flow reactor. So where you have constantly things moving out of the system and coming in the system. And in this case, the concentration can change not just because of reaction, but also because of dilution. Because you have certain amount of water already inside the reactor. The moment you add something, it mixes together and become diluted. Okay, so that's the concept there: reaction plus dilution. Whereas plug flow reactor is really you don't have a system where things are mixing. Okay, what it does it you are just a pipe, things are moving in the system. So if you have a drop of ink, let's say there is a pipe and you drop a little bit of ink, it will move through the system, and the concentration will not change unless there is a reaction. Okay, so that reaction is more like a batch reactor. So think of a small batch, like in the pipe, you take a small cross section, and that water column is moving. And so if the concentration is changing, it's because there is a reaction going on inside it. So a plug flow reactor without reaction, the concentration will not change. Same thing for a batch reactor. The concentration will not change without the reaction. That's why the equation for batch reactor as well as plug flow reactor is the same, is the exponential decay, because that's related to first order rate reactions. Whereas the equation for complete mixed reactor, the equation is different because you have a energy. So for instance, here this is a batch reactor. This could be also a plug flow reactor. The only difference is plug flow reactor, the time is associated with the distance travel. So the T term will be a distance term correlated with the velocity. Whereas if you think of CSTR, you solve these equations and you get answer like this, based on whether it's a steady state or non-steady state. Is it clear?
Yes.
And
Can I ask some questions? Oh,
yes, Hannah.
oh no, I was gonna ask some
Oh,
questions
that
about
wasn't
Oh,
me.
life.
oh, I'm sorry. I saw that there was not. Imam, ask the questions.
It's about half-life, so I want to make sure you're done with this before I can ask, so I don't like change the topic and then come back.
So I want to explain half-life. Okay, so on half-life, if you see the half-life equations, I don't know where is it. Okay, so half-life, the whole concept is this: the left side of this amount of time it takes to decrease the concentration to the half, and that half-life expression is very different whether it's a first order or zero order reactions. The one you see over here, 0.693 divided by K, is based on the first order reaction. It's not based on the zero order reactions. For zero order, you have to derive it. So for instance, those are all derived, it's written here. Okay. So think of the time. So think of here now. So if it is a zero order reactions, you see the equation is C0 minus K by K T0. So you are saying that the concentrations is initial concentration minus K times time. So half-life you can derive based on that. Plot T equal to T half, then the concentration is C half. So if you derive that equation, it will be C half equal to, let me write somewhere. I have to switch stops here and switch to iPad. So let's say for zero order, what is the T half for zero order reaction? Zero order reactions. Okay, so zero order reaction means dC by dt equal to Kc. K, there is no other thing. So if you in that table, it's what it says that C equal to C0 minus KT. The reason is if you solve it and integrate it, c initial minus c whatever time 0 to t, you get this answer. Okay, this is given in that table. So ask what is the t half for a zero order reaction. So that means again you apply the condition t equal to t half, that's the half life. The concentration must be half of where you started. This is your initial, or t equal to 0, c equal to c0. That's the initial. Okay. So what you are saying is at the time when it takes to lower the concentration to half of what you start with. So you plug the value c equal to c by 2 and the t half. Okay. So if you apply this condition here in this equation, you get this value. So what it means is k t half is, if you take the other side, it becomes C0 by 2. So it means T half for a zero order reaction is C0 by 2 K. Okay. Let's see. I'm just going to write it somewhere here in a easier term. So T half for zero order reaction, it will be C0 for zero order. But most of the time it's the first order. That's why it's a 0.693 divided by that term. So that's why you got to be mindful about it.
So I know the half-life varies if it's first order, zero order, second order, but does it also vary with the type of reactor?
No, it's all about
Thank you.
it's all about the concentration, how you determine it. So I think let's see this way. It's a good point to say. When you think of half-life, we are talking about unsteady state, right? Because we are talking about things are changing with time. If things are not changing, there is no half-life. Okay. So when you talk about half-life reaction, we are talking about just the reaction term. We're not talking about the change because of the dilution, all that factor. So reactor come into play when it comes to dilution and other factors. When you think of half-life, I'm just asking the reaction term. So this term is what I'm asking. I'm not asking about the everything else in the mass balance, that floor, all that stuff. So you have to think of, when I ask half-life, it's nothing to do with reactor. It's more about the reaction term. Okay, because the half-life, I'm asking how the concentration change just because of reaction, not because of all the other factors in a reactor. Any other question?
Can you go over the significance of the step input and the step function response again? That was regarding the unsteady state for, I believe it was the CMFR reactor.
Okay, so Emma, let me explain that in these slides using different types of input. Okay, there are two kinds of input. One is a pulse unit where you dump everything within very small time, so that it doesn't change the volume or doesn't change anything. Whereas the step input means you are continuously injecting. Okay, so let's try to pulse input and step input. The reason it calls, just graphically what it means is that if you have a time function here, you increase the concentrations very high very quickly. Okay, but you dump everything in a very short time. So that's the pulse input. So if you say how much you added before the t equal to, so t equal to that spot, you added something. After a certain time, add t equal to t plus delta t, the mass equal to 0. Okay, and what that means is you a little bit before, a little bit after, you didn't add anything else. Okay, whereas in the step input, it's different. The concentration increase and it stays forever. Okay, so this is t equal to 0. Then after it continues to add, so t equal to t, it's continuously the concentration remain high. Okay, so that's the step input. So what's the real life example? So the real life example here is that you dump chemical, which is something given in the example of the homework. Dump one time, nothing else. Whereas this one, you are dumping contaminated stream of water. So something, think of wastewater continuously being dumped into. So maybe that wastewater didn't have any pollutant. Suddenly there is pollutant started. Okay.
And the upper limit that we calculate with this step input scenario, what does that represent in like a physical scenario?
Okay, so what it means that, let's say you started adding, think of your think of a river, right? So imagine this river is flowing, and your goal is to calculate the concentration of pollutant in the river at some point. Okay, so now you started adding wastewater. Okay, imagine the time 0, you start adding. So your goal is to monitor the concentration in the effluents at some point, right? So initially, let's say this is the amount was there. Okay, and but once you start adding, things will improve over time. Things will increase, right? So it continues to increase, but it cannot increase the beyond certain value. The reason is, the moment it will, if you keep doing adding more and more and more, what happens is there is a certain amount will be degraded by the time it goes there. So there is an amount you added, so it will, the amount it increases is based on, this is like the maximum amount. What it means that um, the concentration after that point, whatever the concentration you are adding, is some amount is already removed because of reaction during that flow, and some amount is remaining, and that remaining amount is always increasing that concentrations. So that value is always remain at that point. So that's the steady state. Means, like, that increase in concentration is a function of how much being added, how much reacted. The difference is the amount. So it will be at that locations.
Thank you.
Okay. Any other questions? What about chemistry? So let me show the go to CCLE, and some of you say that I uploaded something homework to. Oh, I see what does that mean. Okay, let me delete that one. That was accident. So let me upload the homework 1 solution. So
I was wondering, in the summary table, there isn't any third order written. It's just zero,
yeah, there is no third order.
zero, first, and second. So does that
Yeah.
mean that like third doesn't matter?
Let's put this way, even second doesn't matter. The reason is, when you think of order of reaction, you are saying the how many of pollutants has to add together. So let's say, what is one order means? It depends on concentration of one pollutant. Okay, if the reaction depends on concentration of two different pollutants, so let's say A and plus B react to form C, that means A and B has to collide to become a reaction. And what is third order mean? Third order means like A plus B plus C equal to some product. So that means all three chemical has to come together, and the probability of that happening is very low. In nature, it doesn't happen that way. It just always happens either first order, means that one pollutant, or maximum second order. Third order, the example is very, very low. So we don't have to worry about that. So I uploaded the homework 1 solution. So let me go through my, oh, let me, so do you guys, what do you see in the screen right now? Do I share my screen or not? Okay, let me share the screen for the iPad again, because I can show the homework solutions. Lectures, but I uploaded that on the CCLE right now. Okay, so let me upload it. Okay, so this is the homework one solution which is uploaded on CCLE. Question one, and I wrote the answer for different things. So you should see the method, and these are usually short questions for the midterms questions, and you get 2 points for short questions, and these are the questions for the midterms. And the quiz are not ask something that takes long time for you to calculate, because I expect you should be able to answer maximum within 2 minutes. So these are the questions that should not take, this should take longer, much longer than 2 minutes, or maybe sometimes such thing. But at least you should know the concept. So here are the answers for all the questions. So you should be able to see those. And if you have any question, you can ask. Again, I'm going to release the quiz today at midnight. So you can ask any question related to quiz until then on Campusware. Once I release it, I'll not answer any questions related to quiz. So you have some time.
I know you said you're gonna post it at midnight, but could you post it at 5 so that like we have some time today and tomorrow? Or
Say again, what's the?
what time are you posting the tech quiz? Is it midnight or 5 o'clock?
Today, not 5. Oh, I mean, what do you? Okay, so the reason is always there'll be issues with some students not having time. The reason I have to pick something with a 24 hours window so that everybody get a chance. Some students say that if I release at 5 p.m. today, they have extra hour of work today, and then when they have class tomorrow till 5 p.m. So it put them in a disadvantaged position to respond to for that. That's why I have to pick a time. So either I can, it doesn't matter what time I release, but I have to have 24 hours window. So either I can release morning at 7 a.m. in the morning tomorrow, and then it's 24 hours from that time. You just have to pick a starting time. That's why I start at midnight, because if somebody is from different time zone, they can do it. But again, 20 minutes will not be a long difference for a lot of people to find that in tomorrow, unless you are traveling. But if you have a special case, whatever reason, you just send me email so that I can arrange that differently for you.
That solution that you just had opened, that was the solutions to the first homework?
Yes.
Okay.
So look at that solution so that you have okay, so there are some questions here. I'm a little confused about what is the carcinogen. Okay, I see some people already answered. Great. I love the chat window because sometimes you guys answer the questions. Again, ask questions via Campusware. I still see that very few people, still like 40 students have not enrolled. So let me share the screen of Campusware so that you can see what I see. So for instance, here, if you go to class speed, I have the solution uploaded. So if you click that one, it should open up. CCL is very hard, many different way to organize, but Campusware I found it easier. So you could go there and just find this out, and then you see there are questions. Students ask questions on I don't. This is what I see, because you can ask question anonymously. So that means I have no way to know. But again, I don't really need to know what's the reason I have to be. And I also see that Vera, she's one of the TA here. She answered the question. Um, so she just said that no, this is how the question was there, so you should be able to solve it. Then again, will the homework solution be posted? Again, I just put it there. So I like Campusware because I don't have to look for your emails in my email box. It is like full with a lot of unread emails. I get so many emails that I don't read it every day. I just look for what's the most, then I may miss it. But here I don't miss because I have it's a different app altogether. So for instance, unread. Okay, I already write. Question 2 part B, what the concentration will be? Time it takes pesticide time for this. So I'll answer that. But you see that this kind of conversation is important because I'll be able to answer that, which will be able to help everybody, not just the person who asked the question. And only 199 in 98 registered. So that means the class is 213 now. So still there are at least 15 students who have not registered yet. So you might miss out all this if you're not registered. So if you are one of them, you should register Campusware. And there is no privacy concern here. I just want to mention because this is compliance with the university, unlike Piazza. The reason why I stopped using Piazza is because of that. And I will upload my annotated slide here today after the class, as well as I'll upload those on YouTube. Any questions you have few minutes left for this class. I just suggest that now don't worry too much of the quiz because this is open book and you have all the materials. Not just that, you have flexible time. So there are lots of advantages of this quiz compared to, let's say, for in-class exam. Because in-class exam is closed book. It should be just you have a cheat sheet and you have specific time. And so, sometimes it's good because you are prepared, but here you have a lot of flexibility because of COVID. So go ahead and do well. Just to get you an idea, a lot of the average for the quiz is around 9 out of 10 most of the time. So I expect that most of you will have answer here. And it doesn't really matter what's the average now. You just try your best. Prepare well this by end of today. Make your cheat sheet because that cheat sheet will help you for also your midterm. So you are not doing extra work for the midterm. So you have now opportunity for up to lecture 4, make your cheat sheet. And that could be as many pages because this is all open work. So this will, once you do that one, you will do well in the quiz and just use the same thing. Don't destroy it. Use the same thing for your midterm. It just makes you be more efficient, not other way. All right, so I think it's now 1:49. Unless you have any question, we can end the class. Let me read any question that from the chat window. So I'm confused about slide 22.
So Professor, whenever you're gonna open the quiz, you will email us immediately to know
when
if it's tonight or tomorrow morning?
When I upload the quiz, I will send email. So that
Okay, and did you decide if it's gonna be today midnight or tomorrow morning?
I prefer today midnight. The reason is otherwise it will just continue to rise now.
Okay, so today midnight. Okay, thank you.
So you can ask any question related to quiz until today midnight. Okay, that's the whole reason. So that way once I upload it, I will not answer any questions if you have doubt. Particularly if it is part of quiz, I'm not going to answer. Can we skip around questions or do we have to answer in order? I don't think it's because you can go back and revise. I hope so, because I have to check on how it's set up on Campusware. not Campusware, on the Gradescope. But my understanding is that you should be able to revise your answer. So I would suggest that answer whatever you want and go back, go forward, and then come back to edit it if you want to. But I have to check, whatever that Gradescope allow, I'll permit that. And most of the time it releases one question at a time, like CCLE. So it might be the similar thing. I have never used Gradescope before for quiz, but I know I'm familiar with CCLE. CCLE will allow, will answer the question until you can go to the next one. But maybe there is a way you can come back and edit your answers for that question before you finally hit submit. I'll send that email to so that I see, because I'll make the questions and I have the TA answer it so that they knows any problems there before I release to you guys. All right, good luck with the quiz and see you next week on Monday. Again, prepare for the quiz, submit your homework tomorrow by midnight, and work on the third homework, which is very simple. And you have to write essay, part of it, about something that you care about or something you want to learn. And that's not graded for as long as I'm just looking at your stories. So, and then some question related risk, which is example given. So it should not take long time for the next homework. All right, I'll end the class now. Stop recording.